Hi. It's so nice to see you again. Come in, come in. Would you like anything to drink? Oh, sorry. I didn't notice you were carrying a drink with you. Do you want to get started? Of course. Come take a seat. So what exactly is it that you need help with? Ah, moles. It's pretty easy to work with. Alright, so get your paper and I will help you. Okay, now, which one do you want to start with? Number 9? Okay. Find the molar mass of the following compounds. Simple enough. So, we are starting with potassium hydroxide. Okay, well, that's simple. You know how to find the molar mass, right? Okay. It's very easy. Let me just get my calculator here. So, to find the molar mass of a compound, all you have to do is find how many atoms are in it of a certain element, multiply that by its molar mass, and then do that until you found... sorry, let me start over. So with potassium hydroxide, we have one potassium, one oxygen, and one hydrogen, right? So we only need to find the total mass of the potassium, add it to the total mass of the oxygen, and the total mass of the hydrogen. Should be easy enough. Let's say it was K2O2H2 instead of just KOH. Then we'd find the mass of the potassium, like the molar mass from the periodic table, multiply it by 2. And then find the molar mass of the oxygen, multiply it by 2. And then do the same with the hydrogen, and then add it up. And we'd have the full molar mass of the substance. Simple, right? I don't know if that substance exists, but it's hypothetical, so don't worry about it. So, anyway, potassium hydroxide. Well, the molar mass of potassium is 39.1, so 39.1 plus the molar mass of oxygen, which is 16, plus the molar mass of hydrogen, which is 1.008. And the molar mass of potassium hydroxide is 56.108 grams. Simple. Now, let's look at this. This is trihydrogen phosphate, H3PO4. So, would you like to try it? Okay, here you go. What did you get? 97.994 grams? Wow, you got that right on your first try. Good job. Is there anything else? Let's see. Grams to moles. Should be simple. So, here's how we're going to do it. Let's start with number 18, seeing as how you've done number 17. Find the number of moles of argon in 452 grams of argon. Well, the molar mass of argon is 39.95. Simple. If we divide 452 by 39.95, it should find the exact number of moles. And it is 11.31 moles. Roughly 11.31. You don't want to have to add all those decimals, but you see. Alright, number 19. Find the grams in 3.26 times 10 to the negative 4th moles of HC2H3O2. Okay? Well, we're going to have to start by finding the molar mass. How many hydrogens do we have? We have 4 hydrogens. We have 2 carbons. And 2 oxygens. Now, we can do 1.008 times, oh, sorry, I forgot to put parentheses, 0.008 times 4 plus 12.01 times 2 plus 16 times 2. And that is 1 mole. We're going to need to lower that. Let me just write that down to keep it. Alright. So to lower it, we're going to need to, let me see. If I haven't done this in a while. Let me see if I can remember. Should be answer times 3.26 times 10 to the negative 4th. Let's see if I remember that right. Seems about right. Yeah, that's right. So we should end up with 0.019, well, roughly that, grams. It's not too hard, actually. And we did that by multiplying the molar mass by how many moles there are. Now, find the mass in 2.6 moles of carbon dioxide. So we have 1 carbon and 2 oxygen, which should be 12.01 and 32. 12.01 being the molar mass of carbon and 32 being the mass of O2. So if we just add those, you'll get 44.01. Sorry, I'm just writing that down. Now, it's 2.6 moles. So, all we have to do is multiply by 2.6. And we will get the grand total of 114.426 grams. It's not hard. Can I try it? Okay. Well, let's see. I'm going to make a problem for you, seeing as I walked you through all the ones that are like that. Let's see. Let's see if you can find the mass of, let's say, 3 moles of sodium chloride. Okay? You want to go for it? All right. Let's see what you got. 175.32. You're doing pretty well. You're doing really well, actually. Should we work the other way? Where we do given unit 2 moles to the desired unit? Well, I mean, like going from grams to moles to atoms or molecules. I see that look on your face. It's not too hard. It's pretty simple, actually. So, let's start with 21, actually. The head of a match contains 1.6 grams of sulfur. How many atoms of sulfur does a match contain? It's pretty simple question. I'm not asking you to do too much. Again, that look. I'm here to help you. You don't... I'm sorry. Do you want us to continue? Alright. So, if we have 1.6 grams of sulfur, and the molar mass of sulfur is 32.06, how many moles would that be? Well, 0.6 divided by 32.06 is about 4.9 times 10 to the negative second moles. And now, we can actually make that easy on us. It's really simple to get to the number of atoms. All we have to do is multiply that by Avogadro's number. It's a constant, kind of like kilometers or feet. The number's not going to change. It's always 6.022 times 10 to the 23rd. Oh, I typed that in wrong. And that should get you 3 times 10 to the 22nd atoms. Was that too hard? Exactly. Do you want to give it a shot? I like the way you think. Go ahead. Alright, number 22. While cleaning a cut, you spill a bottle of iodine. The label says that the bottle holds 300 grams of iodine. How many moles of iodine are there? This one's easier than 21. So, we have 300 grams of iodine. I'm just going to review everything that we've gone through. How many moles? Go ahead. How many moles did you come up with? 2.36 moles? Yeah. And you were worried over nothing. So, is that all? That's it? Alright, well, I hope I was able to help you. It's been good working with you. would you like anything on your way out? You know, food for the road? You good? Okay.